This conference will now be recorded.
Hello, good morning. Can you all hear me?
Good morning, sir.
Good morning. Okay, thank you. All right, let's get started with our demo today. Thank you everyone for joining today on a Saturday morning. Okay, so this course is, of course, DevOps with Azure. So, firstly, an introduction about myself. My name is Kiran, and I have 13 years of experience in IT. I have experience on-premise and public cloud at multiple organizations. Okay, on-premise and public cloud, what are these things? I will explain later. But basically, I worked on, the old type of data centers and also cloud. Um, I I am a certified Kubernetes administrator, so I have good amount of experience on Kubernetes from the last 5 years. I'm also a certified solutions architect and certified Kubernetes administrator. Like I said, I have taken more than 25 training batches on both Azure and AWS, but primarily on Azure, a bit of AWS courses as well. Okay, so that's about me. So before I proceed, some ground rules. If you have any questions, you need not wait till the end. You can, ask me whenever you have a question. But if you're not speaking, please be on mute. If you have any questions, please unmute and ask me any questions. Okay, you need not wait till the end to ask any questions. If it is related to that topic, you can ask me then. Okay, all right.
Okay. Hello.
Yes, please.
Hi, my name is Sirisha.
Hi, Sirisha.
Actually, what is the duration of this course?
The duration of this
Course?
course will be um, 60, approximately 60 session, or let's say 55 sessions. So we will go from, let's say, so it's going to be 10 to 11 weeks, I would say.
Okay.
Yeah, because
And
we are,
one more thing is, will you provide live projects from the beginning by integrating tools and all?
yeah, so we will do a couple of projects, but how we are going to do is we cannot start with the project at the beginning. We will learn each
Okay.
of the technologies, and then, of course, we have to integrate all of them into the final project.
Okay. Okay.
Yeah.
That is done simultaneously or later?
See, I will explain to you what we are going to do at the end. Okay, I mean, towards the
Okay.
end of the
Okay,
course.
sir.
But in this
Okay.
process, we cannot directly start with the final product project, right? We are going to learn each of these individual tasks, right? Because
Okay.
different people might be at different level. Some people might know um, basics of DevOps. Some people might have some support experience. So we will take into account that everyone is a beginner, and we will start from very beginning, from the basics, and then we're going to build one skill upon the other and finally integrate all these things.
Okay, sir.
Okay,
Thank you.
good. Yeah, no problem. Okay, so I'll give you a brief introduction about what is cloud and what is DevOps, and then I will take your questions. But before that, I want to just let you know that what we are going to, what we are all going to learn in this course. Okay, so we learn about fundamentals of IT operations. What do I mean by that? Like, how does an IT operations team function or a DevOps team function? What are the various concepts like networking, okay, um, storage, and or compute mean, and what is a cloud, what is cloud, and what is, let's say, what is DevOps process? Okay, how are these integrated together? Then we will, of course, we are going to learn into Microsoft Azure cloud services, and we'll also do lots of hands-on, obviously. Learn DevOps tool by doing. So we will learn the following DevOps tools. For example, I mean, not exact, I would not say DevOps tools, but these tools that will make you a DevOps engineer. Linux is the operating system that we are going to learn because that's very, very important for any kind of DevOps role. And we're going to learn Terraform, which is infrastructure automation tool, and I will explain to you about that. We're going to learn about Git, how to manage your source code. Then we will talk about CI/CD with GitHub Actions. This is where you will learn how to take code from, you know, and build it into an application and deploy into your, um, VMs or Kubernetes also later. And we will learn about Docker and Kubernetes. Of course, I will give you periodic assessments. I will give you tasks. Okay, like every time we complete a topic, or even before we complete the topic, I give you a task that okay, today you have to do this. Today you have to go to Azure and create these and these and these. Okay, later we go along, I'll give you automation tasks. Then I'll say whatever you did manually, now you have to do them through automation. All right. So this is what we are going to learn in a very nutshell. Of course, detailed curriculum will be shared with you. Um, so that's it. So let's dive in. Anyone has any questions at this time? Okay, if you don't know any of these tools also, that is fine. I'm going to tell about each of them and how they are useful. Okay.
Sir,
Yep.
sir,
Yeah, yeah.
do we need to learn any programming language like Python or like
I'll come.
Bash is the script?
I'll come to that.
In
I'll come to that. Yeah, I'll come
okay,
to
sir,
that
thank
question.
you.
Yeah. Okay, so before we proceed, let's understand what is cloud. Okay, so what is everyone has been talking about cloud and what is it? Okay, so can anyone tell me what is cloud? What is your understanding of cloud?
Cloud is basically where we store our data in network. Through network, we can connect it through and we can what should I say? Retrieve it whenever we want from anywhere in the world.
Okay, that's good.
Cloud
Anyone
is
else?
where we store everything.
Okay,
Okay, let me go ahead.
yeah,
Cloud, as the name implies, is a service rendered to the organizations in
mm-hmm.
forms of subscription. Instead
Okay,
of you to buy your own devices and put them
yep,
on-prem, you
yep,
now pay as you go or on-demand subscription based on those services. So
okay,
it is technically somebody else switches a router and server that you pay
yep,
as you go.
yep. Okay, awesome. Anyone else? Okay, thank you. So rightly said, right? So let's think about this before the era of the cloud. Okay, let's suppose you have an idea to build an application, online application. It could be a um, messaging application, or it could be job portal or whatever. Okay, let's say you have an idea to build a job portal where people can post their requirements for a job and others will apply for jobs, right? So what do you need to do that? First, like, for example, let's suppose you have a team of developers, or you are a group of friends who are developers, and you have developed an application. And when you have developed an application, maybe you do it on your laptop and you show it to your friends and it's working. But when you want to make it accessible to the public, everyone needs to access that. That means whatever code you have developed has to be put in some servers. Okay, so you need server, at least one server. Okay, uh, but as the demand goes on, you have to, let's say your website is receiving more and more requests, you have to create multiple servers. Then there are different components of your application. There is the web front end or the web server. Then there is the uh, business logic where actually, you know, based on the customer's requirements or customers' inputs, you have to show them the relevant jobs or relevant candidates based on who is accessing. And then you have to have some additional servers to store data. Okay, so let's suppose these are all your web servers, web application servers. These are all your, you know, um, business logic processing applications servers or application servers simply, and these might be your database servers. Okay, so at least you need to have two servers each for each different kind of what we call a tier. Okay, this could be called as your front end. This could be your, you call it as back end, or you know whatever you want to call. And this could be your database servers, right? And of course, when you have multiple servers, of course you need cables to connect to each of these things, and you need networking devices such as, you need a router, you need a networking switch, you need a lot of other devices. You need power supply, and you need multiple power supplies, because you plan to operate at a production grade, meaning your application should be always accessible. So what if there is, your power is going down at your home or wherever you're using this? So you have to have multiple power points. You have to have multiple network connections, right? Suppose you use an ISP or internet service provider like Airtel or Tata or whatever it is, and they go down. What do? Your applications will be down, because these servers also need internet so that others can access from these things, right? So you have to have multiple internet connections, and you need to have cooling for all these systems, right? Because you never know, because these are running 24/7, all the time they are running. So you need electricity, you need cooling, you need physical security. There should be someone outside the premises so that your devices are not stored down, because you're running an application. Okay, so you need multiple security guards and all this stuff. Okay, so let's suppose your application becomes a hit. Then you need to buy more servers and start investing more money, and you know create yourself what we call as a data center. A data center is nothing but a you know large building where you put multiple servers and they are connected with different cables and all that stuff. Okay, but let's suppose initially it looks like your website is picking up traffic and everything, but then there are competitors like LinkedIn and you know various other organizations, Indeed, and all this. So maybe you're losing traffic. No one is coming to your website. So then you have a lot of investment already did. You have done already a lot of investment. You have put in a lot of money, but you know your application is not running as expected. You have to shut down all these things maybe, or sell it in the second hand market. So what you need to do is, you have to, before the era of the cloud, you put in a lot of upfront cost. It's called as upfront cost, meaning even before your application is launched, even if the basic version is launched, you have to invest a lot of money, right? Okay. Then maybe your website has increased, but you're not able to scale up your number of servers. Maybe your number of servers have to be doubled. Right now, let's say you have 9 servers, now they have to go up to 16 or 18. But what happens is, when you order these servers, these have to come from Dell or HP or some other hardware vendor who will ship these. Maybe there is a delay. In this meanwhile, your servers might, of course, you also have to buy additional storage. Okay, you have to buy additional storage like extra hard drives and combine them into together into NAS or SAN or whatever you want to do. Okay, so you have to buy a lot of devices, including firewall device and all these things, because you want to have security. Firewalls devices are some security devices which will help you that your systems are not attacked by any kind of attackers in a phishing attack or whatever attack. Okay. Um, So you need to invest on compute, not only storage. Okay, it's not only about storing data, but you have to have compute computers to process the data, or what we call the servers. Okay, so you need to have the compute part, you need to have the networking part, which is, I told you, like all the cables to connect all of these things, right? All the um, load balancers, routers, a lot of other devices you would need. Okay, so that's what we call as a uh, that's what we call as networking components. And then you need storage, right? We're not even talking about the software configuration and how do you automate all these things. We're just talking about the physical aspects of it. Okay. So you have to invest in all these devices, right? But enter cloud. Now we have cloud. You don't have to, you know, um, start investing in all these things initially. So you just go to azure.microsoft.com, create an account for yourself on Microsoft, and sign up for azure.microsoft.com with your credit card. Excuse me, your credit card, and you can start, you know, building your servers. You don't have to buy anything. Microsoft maintains them, but it's like you're renting those servers on cloud and you can use it. It's like, let's suppose, take the example of Google Drive, right? When you use Google Drive, do you have any storage on your laptop that is being used? No, right? The storage is provided by Google for free because they want to promote their products. Okay. And all that you need to do is just sign up for drive.google.com and you can upload your pictures up to a given capacity. For free account they give you 15 GB, which includes your email and everything. Okay, after 15 GB maybe you'll have to spend more money. Okay, so here you're not you're not you don't manage any storage. The storage is given by Google, but you pay for the amount of storage you use. That's one kind of cloud. But when you're maintaining applications, software applications, okay, you need servers also, you need networking devices also. So all of these things are provided by your cloud provider like Azure or AWS or Google Cloud or Oracle Cloud. All these people maintain hundreds of data centers across the globes. Okay, hundreds of, at least tens of data centers, a few dozens of data centers, and you will connect through them through internet, and you can deploy the number of servers you need. So we call them as virtual servers or virtual machines because the physical machines are maintained by the um, actual cloud provider. And you can also create your virtual disks, hard disks, right? So all these things are happening, meaning the cloud provider will have these physical servers somewhere. They will give you they will give you the ability, okay, the way to create a virtual machine from their physical servers. Okay, so if you look at, so but as someone has already said, there is no upfront cost. And let's suppose you have, in the old system you have bought 9 servers, but maybe they're not being used to the extent, only maybe very little amount of usage is happening because not many users are coming. So what is happening, your CPU is used only for 10%, your memory, maybe you have 32 GB of memory in each of the servers, but each of the servers is using like only 2 GB of the RAM because no one is actually accessing your applications. But in cloud, you can choose how many servers you want to build and you will only pay for those servers. What do I mean by that? Let's say initially you built 10 servers for your application. Let's call them VMs, virtual machines. Okay. And then let's say you're using 100 GB of storage. So you started like this. You started using like this for, let's say, 20 days. So for the 20 days, you'll pay only for, let's say, each virtual machine costs. So the billing will be per hour. Let's say what one virtual machine cost is €1 per hour.
Really,
So
you have a new application.
sorry.
Question.
Hey, sorry, your question is not clear. Could you repeat? Okay, I think we'll come back to that. Okay. Um, so let's suppose each virtual machine costs you um, $1. So that means $1 into 24 into 10 into 20. So let's, for 20 days this will be your cost, 240 into 20, whatever, 4,800. Okay. um, so that would be your bill for 20 days. Let's say after a few days you have, you know, increased the number of machines to 5. For the for the rest of the month, your bill will be Okay, so this will become like 10 days. Okay, so you don't have to pay for the 10 virtual machines for the entire month, because after some times you have brought it down to 5 virtual machines. So now you have to pay, sorry, you have to pay only for the 5 virtual machines for the next 10 days. Okay, let's suppose after the next month you have decided that 6 machines would be ideal for you. Okay, then you will pay only for those 6 machines, right? Um, for the entire month. So this is what we call as pay as you go. You will pay only for the amount of resources you're using, for the amount of time you're using. Okay. And second thing, like I told you, let's suppose initially you see that the load is coming to your traffic, a lot of users are accessing it. So you want to give them better experience. See what happens when a lot of users are accessing your applications. That means your servers are getting multiple requests. Okay, in true technical terms, your servers are receiving multiple requests. So that means their CPU and RAM will be over the threshold, like they will go up to 90% or 90% utilization. What happens when you open a lot of apps on your computer, right? Your computer starts becoming slow because your CPU cannot process all the applications at the same time, or your RAM is not enough to open all the applications. So similarly, when a lot of users are coming, you have to have more computers than usual. Okay, so as I told you, if you have a old school data center, if you have to increase the number of servers, you have to place orders with Dell and HP, and they have to ship it to your home, you have to configure and all that. But since cloud providers maintain hundreds of servers, okay, thousands of servers, it's very easy to request new servers and scale up. So let's suppose you started with 6 virtual machines, but you're running 6 virtual machines, but you see a lot of load new users coming up. Maybe you have started a new online campaign, publicizing about your website on Instagram, YouTube, everywhere. All the influencers are talking about your application now, because you're spending money on digital marketing. So now you think you need from 6 to 12 virtual machines. So the old system, it might take weeks to get you servers and upgrade all of them. But here in cloud, you can do it in a matter of few minutes, from 6 virtual machines to 12 virtual machines. So this is what we call as rapid elasticity. You can increase or decrease your number of resources you are consuming from cloud on a very on a very quick basis, in a few minutes. Okay, so that's, so if I have to say about cloud, as someone has already said, cloud is nothing but on demand availability. Like I told you, you don't have to order anything. You have to just go into azure.microsoft.com, sign up with your credit card, and start creating the computing resources or the networking resources you need, or the storage devices you need. You don't have to wait for anything. So that's why we call it as on-demand availability of IT resources, such as IT resources, compute, work, storage. These are the three kind of resources we use generally, uh, where there is no upfront cost. Remember, upfront cost means you don't have to pay anything at the beginning to start using them, and you pay as you go, and the cloud offers rapid elasticity. Okay. So for all this to happen, the application the cloud providers, meaning the people who are managing these clouds, in case of Azure it is Microsoft, we all know that. In case of AWS it is Amazon. In case of Google Cloud, obviously it's Google. They are maintaining hundreds of servers. So if I have to give you a cloud computing definition, this is what it is. So cloud computing is the on demand availability of computing resources without the direct active management by the user. Meaning, direct active management means I don't have to manage the servers. I don't have to manage the physical servers. I don't have to manage the hard drives. I can use them, which are already created by Microsoft. I just need to click on a few links and I can create my own virtual servers. Okay. But on the ground, what is cloud? Cloud is a collection of data centers managed by a cloud provider. Okay. So when Azure decided they will, or Microsoft decided they will create a cloud service, what they need to do is around the globe, okay, they have to create multiple data centers. So things like this. Maybe this is in an under construction phase. Okay, so they have to build a lot of computing or what we call as data warehouses or data centers across the globe, which look like this inside. Inside them, inside the data center, inside those buildings, you will have all of these. Each of these is a server. Like each, this is a server, this is a server, this is a server, and you this entire thing is called as a stack. Like this, you have multiple server sorry rack you like this you have multiple server racks, and all of them are connected to the networking devices, as you can see, and there will be some cooling, there will be multiple electricity connections, not only just one. You might also have your own on-premise electric generator, so that these are always running. Okay, so from the aerial view, of course, they might look like something like, where is this? Yeah, something like this. Okay, they look like a big factory, but inside them they have a lot of what do you call these hardware devices like servers, cables, switches, load balancers, okay, routers. All these things are there. They will have their own power generation unit also, so that they don't depend on only the publicly available power connection. They might have their own power generation unit, and all this physical security and everything is there. Okay, so not only in one place, Azure has to build it in multiple places. For customers in the US, they build data centers in US. For the customers in Australia, they build data centers in Australia. For the customers in India, they have two data centers in India. Okay, so everywhere they build these multiple data centers across the globe. Okay, we'll come to that later when we discuss Azure in our course, but you can already see that they have multiple locations across the globe, primarily focused in the US, but also good amount of presence in the Europe and Chinese region, APAC and Australia. Not much, not it's not almost there. I mean, yeah, these people are talking about both Microsoft and Azure. Um, the orange ones are Azure resources, but I think, sorry, AWS resources, but this is outdated because today we have one more region of AWS in Hyderabad as well. Anyway, we'll come to that later, but you can see a lot of data centers are created by these cloud providers. Okay, so as opposed to the name cloud, everyone thinks cloud is something is in the air. No, but it is all on the ground. It's hundreds of data centers. But you don't, if you are an organization, if you are a company like, let's say, a Flipkart or even Netflix, okay, so Netflix need hundreds of servers to ensure that users can log in, users can provide username and password, users can sign in for the with the credit card and all that stuff. And also they need storage to store all the movies that they are producing, or they are buying from different vendors or different producers. They have to buy those cinemas or movies and put it in a storage. So all these things for Netflix are provided by AWS, for example. Okay, Netflix doesn't have any servers of its. Netflix doesn't have any data center. It is using Azure, AWS resources. Okay, similarly, today even large banks, which already have a lot of data centers with them, they are trying to decommission them. Decommission means just destroy them and moving on to cloud. Some of the old data centers, of course, they're still keeping their own data centers. Okay, so now if some Flipkart, for example, Flipkart is a digital retailer, right? Online retailer. You can buy products and all that stuff. So they need a lot of computing power, they need a lot of storage, they need a lot of networking resources. But Flipkart doesn't have any data centers. Flipkart uses AWS. Okay, because these are the well-known companies, but every company today uses one or the other form, which is in digital services, uses one or the other cloud. Okay, including banks and other people were like very reluctant to move to cloud because it's a what do you call they thought it will be not very secure, but now a lot of organizations are moving into cloud. Okay, so if you think about cloud, how can you characterize cloud? Okay, cloud These are the five characteristics. On demand, self-service. So whenever you want, you can log into a portal and just click and create things without actually interacting with a third party or without actually sending emails or anything. Broad network access. So you should be able to access your cloud resources through browser, through software, through through mobile apps and all this stuff. Okay. Resource pooling. Resource pooling is nothing but you have multiple resources like a data center from which you can create your resources. Other organizations can also can create resources. Okay. It's like Ola or Uber. Think about it, right? When you order a Uber, let's say at 9 o'clock today, yeah, and you use it from 9 to 9:45. That is your till the time from the time you got got into the Uber and gave him the OTP until the time you're dropped off. That Uber car, let's suppose it's a Hyundai, you know, Hyundai Accent or whatever, that car is like yours. You have rented it. You can say, hey, please go into the distance, that distance, and all that. Okay. Similarly, but when you get down, it might be used by someone else. So Ola and Uber has a pool of cabs that can be ordered by anyone. Similarly, resource pooling means in cloud there are hundreds of computers lying around in the data center, and you can request any number of virtual servers. Rapid elasticity, like I told you, you can increase the number of servers from 5 to 10 or 10 to 100 in a matter of minutes, and also decrease them. Not only you don't have to say, let's suppose you created 20 servers today and tomorrow you realize, I really don't need 20 servers. You can immediately terminate 10 servers and forget about them. No more billing, no more anything. Okay, so that's rapid elasticity. You can increase or decrease the number of resources you are using in a matter of few minutes. Measured service, and this is one of the very important aspects. Okay, so how much you're paying for what resources and how long you have used that resources, everything will be given detailed in a detailed manner. You can also use tools like cost analysis and find out where you're spending more money. Okay, that's measured service. Okay, so that's about cloud, and of course we will talk about Microsoft Azure in our uh, discussion. Okay, Azure is one of the big three and fastest growing cloud providers. What are the big three? You have Amazon AWS, which is the leader because it started in 2006 itself. So it's a big leader in the market. Azure started in 2010, but it has a lot of enterprise presence already because a lot of people were already using tools like Active Directory, Exchange, Outlook, and all these things, right? So they have captured some of the market and they are also growing faster. And the third one is Google. Okay, so these are the leading cloud providers today, but Azure is really growing faster. Okay, so yeah, we will learn about Azure, how to use Azure portal and create our resources and automation and all that stuff. Okay, any questions so far on the cloud part? Okay, remember, it's not only about storing data somewhere and accessing it, it's also about the processing capabilities. Okay, storing data is one part, but you also need the servers to do the computational part or the applying the business logic and all that stuff. Okay, all right. So let's move into the next part, okay, which is DevOps. Again, if you have any questions, please do ask me. Okay, let's proceed to discuss DevOps. Okay, again, can anyone tell me what DevOps is? No one, don't have to worry, like there are no right or wrong answers. Whatever you understand from the term DevOps.
Hello.
Yeah,
Okay. Let me give my simple definition.
yeah,
Um, DevOps is a synchronization or it's a collaboration between development team and operation team
yeah,
to um, to achieve a common goal or to provide a value to the end users.
yeah, yeah. That's right. Okay, so traditionally there are two kinds of teams within an organization. Okay, so you always had the software development team, the developers, the people who write code, right? Or what we simply call as dev team. Okay, and then let's say there are multiple engineers here, what we call them as software engineer, right? Okay, and then we have a set of IT operations team. Okay, so these people are responsible for managing the applications and also the servers on which these applications are running. Okay, so you might have multiple, let's say, virtual machines, physical servers, doesn't really matter. So this is where, so what happens is there is a team which develops the application, meaning they actually write the code and they test the code. Maybe there is another team called as QA team also somewhere here, or as a software quality assurance or simply quality assurance. Okay. So then there is this central piece where actually they develop the code. Okay. So developers contribute to the code. Quality checkers or QA assurance team checks the code quality and see if it's working as expected. But the ops team take the code and put it in the servers. Okay. So the ops team's responsibility is to make sure your application is always accessible, the servers are running, okay, and if there is any issue with any of the servers, it is immediately fixed. They have their own you know monitoring method and everything. So their responsibility is stability. Their main area of focus is stability, meaning the application should never be unavailable, or it should not, like, users should not complain that it is not doing what it is supposed to do. Okay, meaning, let's suppose you access flipkart.com, you click on add to cart, but it deletes from your list. That should not happen. Okay, that's an error. Okay, so if that happens, of course IT operations team has to sit in and troubleshoot and see what's happening. The software development interest is to add as many features as possible. Adding features means making changes to the source code. Okay, so what do I mean by that, right? So when you develop an application, it will have some basic features, but every day you keep on adding new features. You add new changes to your applications. Like I always give this example, think about WhatsApp, right? So when WhatsApp was launched around, I don't know, 2011 maybe. Okay, 2010, 2011, it was only a simple text messaging platform, meaning you can send messages and receive messages just like SMS, but it was working over the internet. Then WhatsApp added new features. They said, hey, now you can send emojis. Now you can send, later they added, you can send images as well. You can send photos and receive photos. Then they said, hey, know what? You can also send voice messages now. Then they said, we are just not a text messaging platform. You can also make calls from WhatsApp. Okay, but this did not happen in a single day. This happened over a few months or few years. Later, they added new features, like if you think about latest features, now you have the stories or status, and then video calls, group calls, and they have started something like communities. So every application keeps on adding new changes. Even if it's a banking application, they need new changes, they add new features. So that responsibility falls under software development. Their product, their leaders are saying that, hey, we need new changes, new features. These people's leaders are saying that, hey, we need stability of the application. This application should never go down. So there is an inherent conflict, because whenever you introduce a new change, what happens is there is some kind of um, there is a possibility of errors. There is a possibility of downtime. Your servers going, not servers, your application or your code running in these servers might not function as expected. So your end users might complain. So there is an inherent conflict between software development team and IT operations team in terms of speed versus reliability. Okay, so these people want more speed. When I say speed, they want to add more features faster and faster. So when you introduce new changes, always what happens in IT is it not only in IT, anywhere. If you introduce some new changes, obviously there is a chance of errors. So these people are focused on reliability. There is some conflict between them, and also what is software development team is doing, the IT operations doesn't know. Then came this idea of DevOps, where they said, okay, everyone is working for a common standard, that is making this application as powerful as possible or as stable, and also delivering features faster. Everyone's interest is the same thing, right? They're working for the same organization. So how do we make sure, okay, how do we make sure all of this is like, you can do all the changes, but you still need to achieve speed and also achieve the stability. So then they said these two should not operate in isolation. These teams should work as a single unit. Okay, of course, a developer is still going to develop applications. A DevOps engineer or an IT ops engineer is going to focus on servers and speed and everything, and quality assurance team will focus on the quality. But right now, um, with the concept of DevOps, they're organizationally same teams, or report they have the same priorities, that is maintaining the stability and also delivering more features to the end users. You have to do both of them. Not only keep your application up to date with new features, but you also have to make sure the application is running, you're also running with stability, and there are no issues, there are no errors, or your application is not throwing errors like, okay, not unaccessible at this time, or try after some time, or server errors. You should not receive all those errors. Okay, so the idea is to bring the development team and operations team together, and make sure you can add more features every day, not every day, at least every week or every 2 weeks, and please your customers. Of course, why do you stick with WhatsApp, right? Because they keep adding new features. Not only that, they're very, very stable. Okay, they are very, very stable. When you send an image, you are 100% sure it is going to the other person. Yes, there are very, very, very rare cases that where you see outage meaning your application is not working as expected, but that's very, very rare. Okay, so but they're also adding new features. They're always giving you new delightful features and all that stuff. Okay, so for example, they added this one-time message, right, where you can send a message and it will be, once the other person sees the photo, for example, it will be deleted immediately. Let's say you're sending some confidential photo or something that you don't want him to save on his phone. You can send this with the new feature where you press on that, or you can put you know you're gossiping about your colleagues and you want those messages to be deleted. Now WhatsApp has that feature where you can set a timer to delete all the messages, right? So there are different kinds of features that are already constantly being pushed by by WhatsApp team, but also they are doing it with good amount of availability and reliability, meaning your application is always working. So a DevOps team, DevOps is not about a single person, but it's about a culture, like someone said, to bring in both the software and the operations team together and make it work. Okay, but just by putting everyone in the same team doesn't solve all the problems. You need to have to increase the speed and also to increase the quality. You need automation. You need to give the developers the ability to test something, a new feature faster, and also they should receive the feedback faster. Receiving means what will happen when the code is deployed on the service. Is it working as expected? What is the error it is throwing? And once they have the feedback, they will work on it, fix it, and push it again, push the changes again. So this is a continuous development or continuous uh, what do you call software development life cycle. So to aid in different stages of software development life cycle, you need automation. For example, tomorrow your software development team says, hey, we are launching a new feature, so we need more servers. So you should be able to create these the extra number of servers in a real quick manner. Okay, so you need automation for that, or you need automation to take the code once the developers push the code here and put it in the servers. Okay, through automation. You don't have to do it manually, or the developer should not do it manually. It has to happen automatically. Okay, so for this you build CI/CD pipelines. So that's why a new skill set has also come. Though DevOps is a team culture, though DevOps is an organizational practice, okay, now you also need specialized skills to make these things happen faster. Okay, so that's why I said we are going to learn various tools like, we have to understand how version control works. So, like, how do developers check in the code? Where is the code residing? So, let's say like GitHub. And how do we automate infrastructure provisioning? How do we mm, how do we take the code from the developers and put it in the from GitHub and take it and put it in the server CI/CD? That's called as continuous integration and continuous delivery. Okay, how do we do this? How do we set up the monitoring for all the applications we are running? Okay, then a new kind of deployment strategy has come into picture. Now you don't deploy your code directly on the virtual machines or servers. You have containers. You might have heard about Docker, for example, right? So you have to understand how Docker works and how Kubernetes works, because developers should focus on what are the new features they are going to add, okay, and how your application can be working very well. They should not be bothered about how and where it is deployed. So the DevOps team is responsible to do all this stuff. Okay, they are responsible to create new infrastructure. Let's say the DevOps team says, hey, we are starting a new service, so we need a new GitHub repository. So that is your responsibility. Okay, or they say we need, let's say, new Kubernetes cluster just to test something. We want to do a POC. So you have to make sure you create that Kubernetes cluster in a few minutes, right? So in fact, something like secrets management, where do you put all your secrets like passwords and everything? All these things fall under DevOps responsibility. Okay, so DevOps is today not only just a culture; it's more about things like a specialized skill set that will help in developer velocity. Developer velocity means it will give the developers the power to develop faster and deploy faster in the target servers. Okay, so if you look at the standard definition, DevOps is a set of software development practices that combine software development and information technology operations. That's what I told you, right? To shorten the system's development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objective. Meaning, you have a business team that says, "Hey, we need to deliver new features." Okay, like for example, Flipkart. Flipkart says, "Hey, we need to have what is their business objective to increase the customers, right? To increase the number of sales, not only customers. So how do they increase the number of customers? They have to offer new features, or sorry, new offers and all that, but also they have to give that customers that experience that, okay, Flipkart website browsing is really good. I just look for webcam and it gives me the right suggestions. Okay, and also it gives me and all the different price comparisons. And users should also have the ability to sort by different brands or pricing and all that stuff, right? So you have to continuously update your systems and keep it up to date with your business alignment. So that will be done through a DevOps team. So DevOps team is not only the one that promotes this culture, but also gives the developers the ability to develop faster. Okay, so DevOps is equal to people plus practices plus tools. So you definitely need these tools also to develop this. So you say that, we are a DevOps team, everyone will sit together, we are following all the DevOps practices, right? But you also need these additional tools to additional skills to be able to do DevOps, right? So DevOps aims to create better coordination between development, QA, and operations team and speed up software release with utmost quality. Okay. So not only software release speed, see, release meaning every day or every week or 2 weeks you get some new updates from your products. So that has to be, uh, consistently delivering new features and also with utmost quality. Not only new features, no matter how well you develop some applications, after some time there will be some bugs. Bugs meaning issues. Like, let's suppose, you're pressing enter but it is not recognizing that enter option. Okay, something like that. So that has to be fixed. Not only new features, but if there are any errors, they have to be fixed. Okay, so what is the primary aim of DevOps in DevOps culture is to build and release software quickly and maintain applications with high availability and resilience. Okay, so you develop new features, you push them, but also you maintain applications with high availability, meaning applications are always running. Resilience means even if the application is failing or application is running into some issues, it has to be immediately fixed. Okay, so what does a DevOps engineer do? He manages the IT infrastructure for an application or a set of applications. Okay, so it depends upon the type of organization you're working for. So some teams have, like, each team or each application team has their own DevOps engineer who is responsible to fix all the issues related to pipelines, infrastructure, and everything. Okay, or sometimes you might have a central DevOps team which is working for all the applications. There are different software development teams, but there is one central DevOps team. Okay, so you have to maintain tooling for create and also maintain tooling or tools for infrastructure provisioning, configuration management, application deployment, and also monitoring. And basically, most importantly, you have to automate, automate, and automate. So you have to do a lot of automation. That means we will have to deal with scripting also. Okay, uh, so we have to write some shell scripts and deploy them through GitHub Actions or Azure DevOps, or let's say Jenkins, whatever the tool they are using, you have to use that and deploy it. Okay, so this is a DevOps engineer's responsibility in a very short, brief way. Okay, any questions now?
My question is this:
Mhm.
this training, is it going to be tailored to certification or is tailored to hands-on and job scenario?
Okay, so this is not tailored for any kind of certification as such. There are a lot of certifications, but what we are trying to do is not focus on, let's suppose, only Azure and dive deep into all the aspects from the certification perspective, or let's say, so our understanding is to understand. So our effort in this course is to gain horizontally knowledge and also hands-on practice on these tools. So we learn Linux, we learn Azure. Even if you are someone who is beginning into IT or have some experience in IT, so it gives you that ability to, let's say, you can say, after, I mean, of course, not only this course, after this course you have to practice for at least 1 to 2 months whatever I've taught you. It gives you the confidence to say, yeah, I can put at least 2 years of experience as DevOps engineer, and I'll start giving interviews. So it's more about a job oriented training rather than a certification oriented training.
Okay.
Yeah. Any other questions?
Hello, will you be teaching Ansible and Jenkins as well? Jira, or
No,
only
no,
the you mentioned
no.
before?
Yeah. So that's that's what I have mentioned here as well. So I used to teach Ansible, but right now, because a lot of the companies are moving towards containers and Kubernetes, Ansible might not be really, really, yeah. See, it might be some organizations are still using it, but I'm not particularly teaching Ansible. Um, but I can definitely, I'm not promising, but if there is a time, we can definitely have one or two classes on Ansible as well. Not a big problem. But I'm not teaching as of now.
Okay,
Yeah.
so that is not
Um,
much required. You're
I would
telling.
not say not much required. It depends upon where your application, where your organization is doing. But the thing is, we can add at least two or three more tools. It becomes, you know, like I want to give a very quality training in which, like, whatever tools you're learning, you learn it well. So if I increase the number of tools, it might, the quality might come down. So Ansible is being still used, but if you use
Mm.
Kubernetes and if you use cloud like Azure, there is very
Mm.
little requirement of Ansible these days. Okay.
Okay, and
So
what
that's
about
why
Python, sir? It is
Python,
required to learn for
no,
Azure
no, if
DevOps.
no, I will come to that. Okay. I'll come about programming or, scripting part.
Okay,
Yeah.
okay,
Um, but these are the tools at a very large level, high level. Like I said Azure, but in Azure, we are learning multiple things like virtual machines, auto scaling. We are learning about Azure load balancers, Azure storage, Azure file storage. Okay. We are learning about managing Azure account, users, subscriptions, all this stuff. Okay. And how to use Git, how to use GitHub. Both are different. Okay. Git is a software, GitHub is a platform. Okay. I will also talk about Azure DevOps repos, and then how to build your infrastructure automatically with Terraform. Okay, how to create virtual machines with Terraform. I will teach about that. And then you asked about Jenkins, right? So instead of Jenkins, we are going to learn GitHub Actions. Okay, GitHub Actions is nothing but Jenkins like platform integrated with your GitHub already. So lot of companies are now pushing for GitHub Actions. They need people who have experience in GitHub Actions. Okay, so Jenkins is still being used, but you know people are slowly moving to modern deployment strategies using GitHub Actions. Okay, so we will focus on GitHub Actions, which is again CI/CD tool, which will give you all the capabilities of Jenkins, but it is available within GitHub. Okay, the reason I'm doing GitHub Actions and not Jenkins is previously I used to teach Jenkins because GitHub Actions is more in demand these days than Jenkins. Okay, but
Okay.
again, if you learn one tool, you should be able to also learn other tool. It will take some time, like let's say 1 or 2 days for you to pick up the new tool. But if you understand the concept of a pipeline, if you understand the concept of integrating your source code repository with a CI/CD tool, it is not too difficult. Okay,
What about Marvin?
monitoring, you mean?
Yeah.
Yeah. So again, that will be part of your Azure because I'm primarily focusing on only Azure Monitor. I am not going into any third-party tools like Prometheus or any other tool. Okay, but there is a tool called as Azure Monitor, which will give you the ability to monitor your Azure resources. Since we are focusing from the infrastructure on Azure, so I will focus on Azure Monitor.
Okay. So Marvin is majorly for monitoring.
Yeah.
Okay.
Okay, so the project will be very simple. Okay, we have to build all the infrastructure through automation using Terraform. Okay, let's suppose we are a startup, we have a simple Java application. So firstly, what we do is we build everything on Terraform, meaning the required systems for this startup. We'll assume there is a startup. Okay, then we won't write the code because we are DevOps engineers. We will not write on the code. We will take an existing code and we make sure this code is built deployed onto the servers which we build with Terraform. Both of these things will be automated end to end using GitHub Actions. Okay, so everything is managed through code. Today, everything is working through code. You will do less with UI. UI in mean you don't go to the Azure portal, but you do it everything through Terraform by writing code. Okay, then you push it through GitHub Actions. So we'll focus on two primary aspects, but that covers everything. We'll focus on infrastructure as code automation. We'll focus on CI/CD. Again, within CI/CD, we do two parts. First, we do it on VMs, virtual machines, and then we actually do it on Kubernetes. Okay, so to do it on Kubernetes, of course, we have to build our Docker image. So our project is take a Java application code and deploy it onto virtual machines as well as Kubernetes cluster as well. But before that, how do we do the preparation? We do the preparation with infrastructure as code. Okay, maybe one session we could also use Ansible because we are talking about VMs, right? How to set up the VMs automatically also, or configure the VMs with Ansible. Okay. So again, all these things we are doing it through code, and this both these things we are going to run it from GitHub Actions. Okay. And of course, why do we need to learn Linux? Because all the VMs will run Linux operating system. You have to understand how to install various tools first, and then we will automate that. Okay. So that's the idea, right? And when you're managing code, you have to understand how to use Git. Git is a version control software or a command line tool which will help you to save your code in a GitHub or anywhere, and then how do you do that? Okay, so as part of this, we'll learn about branching strategy. Okay, I'm not going to teach Jira and all, obviously, because that's beyond DevOps skill set. But of course, it's good to understand what is Jira, how it works. Maybe I'll show you an example, uh, or whenever we are discussing items like you know CI/CD, I will explain where Jira comes into place and all that. So we'll understand branching strategy, we'll understand PR mechanisms. Okay, so everything we dive in deep. Okay, so we talked about automation also when we talked about DevOps responsibility. So how do we do automation? So we will learn about Linux operating system, and also we'll learn about Linux shell scripting. I'm not teaching Python. It will be really good if you have Python experience, but even if you have shell scripting experience, or some people call it as bash scripting, okay, that itself is really good. So I'm going to teach you really basics from how to create a basic Hello World Linux program to, some advanced programs, how to use if loops, how to use for loops, how to use variables, all these things I'm going to teach you. So even if you don't know any kind of programming, any kind of coding, not to worry. But you have to remember one thing, we will do a lot of coding in our programming, in our course. When I say a lot of coding, it's not like developing from the scratch. It's not right. It's not like writing Java applications. It's not creating new business logic. For example, as I said, Linux shell scripting is very basic. We learn that. And again, Terraform, it uses its own language. Okay. So it's a simple configuration language, not a programming language. So it uses a programming language called as HashiCorp configuration language. And again, Kubernetes, right? For GitHub Actions, for instance, GitHub Actions and also even Kubernetes, you have to know how YAML works. It's another configuration language, not a programming language. So we just need to understand how to write this. It's like basic English only, but you have to put it in a particular order. Okay. Now we'll learn bit of Azure CLI shell commands again. It's like Linux shell commands. We learn about Azure CLI. Mm, what else? Yeah. Again, Ansible. If we are going to learn one or two lessons, it's also going to be on YAML language. Okay. Um, yeah. And of course, when we learn Docker, there is a concept like Dockerfile where we write the code. Again, this is a configuration language, not a programming language, meaning you just need to understand the syntax, where to put what. You're not writing new business logic or anything. Okay. So there will be a lot of coding involved, but that doesn't mean you're programming. You're writing code. Basically you're taking the templates and developing it. There is a structure. You have to understand the structure and make changes as per your requirements. And that becomes your Kubernetes YAML file or GitHub Actions file or Ansible. Yes, it's all writing code, not clicking on the portal. Yeah, so you will do a lot of work with keyboard than mouse. Okay, you will have to understand concepts like variables, environment variables, how to update these things, how do you substitute these things. So all this mostly I will try to cover in this part, which will also be useful in your Terraform, Ansible, everywhere. Okay. Okay, now questions. Okay, yeah, let me complete this, then I will open up for questions. So what the bonus, I will give you interview tips. Okay, not only towards the end of the end, but for each topic I will tell you, like, what kind of questions you can expect from the interview. And I will give you notes and cheat sheets. When I say cheat sheet, it's nothing but I will give you the list of commands that you need to remember. Okay. um, or that will come in handy. You don't have to buy hard anything, you just need to understand the logic. And resume tips, how to prepare your resume. I mean, I can't give you a lot of resumes, real-time resumes, but if you want, you can send a resume to me and I will review that and give you what changes you can make. And I will also, because today everyone is talking about chat gpt, I will talk about how you can use chat gpt as a DevOps engineer in your day-to-day operations, and how you can learn from that. Okay, so you can, I mean, for example, we are learning Terraform, and I will tell you how to use chat gpt while using Terraform. Or you are writing a Docker file to build a Docker container, i will I will show you what are the possibilities of using ChatGPT to get your thing done. Okay, so that's one thing I'm going to cover for each topic. I mean, it's not going to be like, okay, now let's go and do ChatGPT, but whenever I try to do something, instead of you know searching entire internet, I will go to ChatGPT and ask for, okay, how do we do this, and I'll show you. Okay, so I already answered some of your questions, like regarding programming. If you know programming, awesome. You have better chances than many others. But if you don't have it also, that's fine. I know a lot of DevOps engineers who have not even worked on shell scripting, but they're still surviving. But you have to learn automation, so you have to learn scripting. Okay. Yeah. Eventually, if you're becoming a senior developer, a senior DevOps engineer, then you have to learn Python. Maybe if you're putting 7 8 years of experience, you have to show that you know at least one programming language like Python. Okay, even if you don't develop, you have to have that understanding of Python. Okay, so besides that, what do you need, right? You need a computer, obviously. Not on phone. I would recommend always attend any session with computer only. A laptop or desktop doesn't matter. Okay, you need to create some subscriptions. First thing is Azure free tier. It is free, but you need a credit card to sign up. Okay, and this is free only for 1 month. For the second month, maybe you will have to pay some bill, like it will be like 500 rupees or 200, maybe at the maximum 1000 rupees per month. That's one time, but you can keep that account. And see, as I said, cloud is pay as you go. If you are using for 10 hours in a month, you will pay only for those 10 hours, and what kind of resources, that also depends, right? So we'll talk about how to manage your Azure account actively and get minimal bill. But don't worry, if you're spending 1000 rupees on Azure bill for a month and practicing, that's a good investment. Okay, in your career. So we need GitHub account, which is free. Again, you don't need even credit card for that. We need Docker Hub account, which is again free, where you will push your Docker repositories, Docker images. So that is also totally free, you don't have to worry about that. Okay, you need to install some software on your computers. For example, Git, Azure CLI, Terraform, Docker, VS Code. All these tools you will install on your own laptop. Okay, of course, if you can't afford to have your own laptop, you only have work laptop, even then you can do everything on Azure. That's not a big deal. Okay. You can create a virtual machine and do it everything on Azure. That is also fine. Okay. So personally, as I said, programming, you have programming, you don't have programming, you don't have any IT experience, all this is fine. But what I need is active participations. Why do I say active participation? Is people join from their phones or iPads. That's not active participation. You need to open your laptop, sit up on a desk. Okay. Maybe if you're used to taking notes on a physical pen and notebook like the old style, not the notepad on your laptop. I'm talking about a notepad. That is also very good. You can sit up and take notes, because when you take notes, your concentration increases and also retention also increases. Okay. And also attending the classes, listening to the classes is one part, but you have to have daily practice. Okay. Whatever I teach in the class, I might or might not give you any tasks, but you have to practice whatever is taught in the class. And a lot of the people I see, again from my experience, and it's very unfortunate, when they join they are all enthusiastic, I need to know this, that, but when I start giving them tasks and I ask on the next day, okay, have you completed the task, the response is like this: silence, absolute silence. Either they are not doing it or whatever. So if you're spending money on this course, if you're joining this course, investing your time, okay, you should also follow up with the practice. Okay. And a lot of the people think that, okay, I will listen to the session, entire course, and then I will start practice. But this is going on a cumulative basis. Every day we learn something new. So every day you have to start that practice and be thorough with that part, then only you can move to the next part. If you don't understand shell scripting totally well, okay, then there is a very little chance that you understand Azure CLI well. Or next we move to Terraform. So if you don't understand to write a basic shell script or basic Linux commands, it might be very difficult for you to understand Terraform. Okay, so on and so forth. So I would say you have to practice on a daily basis. That's my point. Okay. All right. Now I'm open to questions. All yours.
Okay, based on the practice side, will you be giving lab tests, or you expect us to be practice while you are doing your own, or what is the mode of
Yeah.
doing that?
Yeah. So in today's world, you don't need a lab. Like I said, you can create a Azure portal, right? You can create an Azure portal, and everything you practice is on Azure portal. You write your code, whatever code, it could be a simple shell script or whatever. You can store it on GitHub. Okay, so you have labs at your disposal. So I'll show you how to use your Azure to create your resources and how to start practicing on them. Okay, you want to build a web server on Azure? Yes, you can do it. You don't need any specialized labs now.
Okay.
I mean, yes, the lab is your Azure subscription.
ఫోన్ ఎత్తితే ఫోన్ ఎత్తినాం అనుకో మధ్యలో
Excuse me.
Yep.
Yeah. And I want to talk regarding this timings. Can you shift 1 hour before, like 6 or 7, 7 to 8? Because this is special. Because I have a kid, that's why he's just baby. He need to go to school. That's why I have a this. I'm asking for this. If
Yeah, I understand.
it's okay, uh, if it's okay
Yeah,
for you, I want to directly talk to you because you're the mentor here. Uh,
yeah, I know, but yeah, I will just check with my colleagues at
Please,
Career
if
IT and
you
see
could
what is.
do 6 to 7, that would be really helpful. So I that
Okay,
that is
67,
my
67 might be like almost impossible. As you might have
impossible.
seen,
Then 7 to 8, seven to
yeah,
eight is also good.
yeah, I will speak to my colleagues at
Please
Career
just
IT and
think
see.
about that.
Yeah, yeah, yeah.
Please,
We'll let
please,
you know by tomorrow.
please. Yeah, I'm very curious about to learn, and I really like your session now. I want to join, enroll, because of this thing, my kid he's just baby. Uh, I don't have much time. I can't put those 8 to 9 a.m. That's right.
Yeah, I mean, yeah, I can't promise anything right now, but we'll update you on
Okay,
that. Yeah.
sure, thank you. Or evening session, if not morning session.
Yeah, evening would be much more happier for me, but depends
What
upon
are the
what are
timings then, sir?
maybe something like 8:30 to 9:30 p.m. or I don't know. But again, we are primarily targeting at the morning session right now, but depending
Morning?
upon others, we'll let
Okay.
you know. Yeah.
If you could shift that to 7 to 8, that would be really helpful. Please just think about that.
Yeah,
Thank
sure.
you.
Yeah.
So, sir, so there's no need to learn SQL database then, if
Yeah.
there is no requirement
So
learning for
generally,
DevOps, Azure with DevOps.
yeah, generally we don't venture into the side of, let's say, um, we don't venture into the side of creating SQL queries or running SQL queries.
Okay, sir.
Uh,
Okay.
we our
Is it
responsibility is,
required?
it's good if you have it. See,
Okay. How
DevOps
that?
is DevOps is a wide area. Like people have uh, different organizations have different standards, different skill sets requirements. Okay, but I will
Okay, sir.
talk about Azure SQL databases. What is a SQL database? How to create it, and all that stuff. But for the SQL commands itself, it would be good if you learn. But
Okay.
again, there will be like a lot of requirements for a DevOps engineer. Even if you satisfy some, you prove that you have 70% of that skill set, that is enough, because it's good. It's difficult to find for any organization people with everything you need. Okay, so they
Okay.
will put like, let's say, 7 8 requirements. If you are able to prove in the interview that you're good with the 5 of them, okay, and also you have some knowledge about the other two, that's good enough. Okay, so
Okay.
one thing is, e- it's a continuous process, it's a continuous learning process.
Mm.
So as you grow in your DevOps career, there will be more and more skill sets you have to acquire, right? So when I
Mm.
started, I was only managing servers on Linux servers and doing everything through shell scripting. Then came other tools,
Mm.
right? Ansible,
Okay.
Terraform, and
Okay.
then came Docker. You have to learn Docker. Then came Kubernetes. Then came GitHub Actions. Everything
Mm.
earlier, setting up a pipeline is a thing you do it on UI. You just click on
Mm.
this, that, and that. But now you have to
Okay.
write a small YAML file to write your CI/CD pipeline also. So yes,
Okay.
Kims, you have to continuously learn. But when you start as a junior DevOps engineer or someone like that, the
Okay.
expectation is not that you know everything. Okay.
Okay, sir. Thank you.
Yeah. Yeah.
Hello.
Yeah. Yeah.
Okay. And so now that we have Azure DevOps platform,
Right. Yeah.
before now in the industry, what are you guys using before now to get the job done?
Okay. Yeah. Like I said, right. If you talk about even 2015, a lot of this stuff is happening manually or through some shell scripts. Okay, and we still so Jenkins was still around, so we were using Jenkins. We were using let's say there is another tool from IBM called as Urban Code Deployment, UCD, Urban Code Deployment actually. Okay, we were using tools like that, which are still there in the market, but they're kind of fading away. Um, and yeah, everything was on premise, right? Most of the uh, things are on premise, meaning they are running on our, let's say I was working for a company like JPMC, for example. So they have their own data centers, and there is a separate data center team who will exclusively work on the physical infrastructure, and there is a hosting services team who are responsible to give you services. For example, your team says, okay, we need two new servers for our POC. So you make a request and it goes through an approval mechanism, and someone else approves it. And then after 2 weeks, they say, hey, here is the IP address for your servers. You can access them using so and so credentials. Okay, whatever. So there was tooling, but it was mostly inbuilt, like made within the organization, or it is mostly manual. That's how things were.
Okay. Thank you.
Yeah, you still apply the same principles, like you prepare a server with all the requirements. Let's say you're developing a Java application, then you make sure you install all the Java components, JDK, and then you know you make it ready, and then the developers say, hey, here's our code, please deploy it. Okay, so we will run a manual build job or through an automated pipeline like Jenkins or something and deploy it on the servers. Today we do that everything on cloud, and everything is more automated with less chance of errors, right? So back in the day, you can think of errors like, yeah, you installed one version of Java on one server and another version of Java on another server. But with automation, these things will be kind of addressed to a large extent.
Okay. I have one of my sisters. She's
Hmm.
working as a DevOps engineer in one of the company.
Hmm.
I work as network security engineer. I work on
Okay.
firewalls.
Okay.
So she usually work on Jenkins. So
Yeah.
now my question now is, um, most of the tools you mentioned is
Hmm.
relatively consigned to the cloud. What about on-prem devices? Maybe what we want to deploy on is majorly on-prem. Do we have something that can work in hybrid environment like that?
Yeah. See, so instead of Jenkins, I told you we are going to discuss GitHub Actions, right? So GitHub
Yeah.
Actions. So even if you're on premise, you would need something like GitHub Enterprise Server. Okay, so GitHub can be a cloud service, meaning you don't have to install anything on your data center, or GitHub, you can run it on your own data center using GitHub Enterprise Server. Okay, so when you're using GitHub Enterprise or GitHub Cloud, it really doesn't matter. You still have the same ability to deploy using GitHub Actions. Okay, so in my previous organization, I was working for a large bank. Okay, so they had everything on-prem, but the deployment was happening through GitHub Actions. Okay, because they were initially on a different tool, but then they wanted to migrate to GitHub Actions across the bank, across the organization. So we started onboarding them onto GitHub Actions. So yeah, you can still use the same tool. You can still use Terraform even if you're using VMware. Okay, you need not be on Azure. You can still use Terraform. Kubernetes, for example, again, you can run it on your own data center. Okay, we have tools like OpenShift, which is a Kubernetes cluster, but um, there is some kind of additional layer on top of Kubernetes, but you still need to understand how to write a Kubernetes file, manifest file, or you still need to understand how to deploy Docker images. So these are all same, except for the cloud infrastructure part. Everything is going to be same, Abhi. There will be like few differences here and there, but yes, you can use all of these on an on-prem environment as well.
No.
In cloud,
Uh,
everything gets easier. You don't have to spend one day deploying a Kubernetes cluster on on-prem. On-prem, you have to do that. On cloud, you can deploy it in a few minutes, 2 minutes maybe. That's the difference. And particularly what happens is when you're on-prem, right? You might not have the full freedom. Like you already know you're just handling the network security, for instance, right? There might be another team which is handling only the hosting services, who are responsible to give you create a server and give it to you. But when you're on cloud, you don't have to wait for anyone. You just run a Terraform script and it is created. That's it. Okay, if you don't have any questions, I don't want to hold you up on a Saturday morning.
Kiran, I have one question, Kiran.
Yes, please go on, Shiva.
The last month also I joined for these classes, but due to some issues, it got cancelled.
Yeah,
Again,
so
I'm going to enroll for this DevOps for this.
yeah, so yeah, really
Currently, I'm
sorry.
working. Yes,
Mm,
Kiran. Yes, sir. Please
mm.
proceed.
Yeah, so there was some, we expected more people, but it was an evening batch, so there were less attendance. So we thought, okay, we'll try the morning batch. Yeah,
Yes,
hopefully
yes.
this time we'll have more people. Yeah, go on, please.
So currently, I'm working as Linux administrator in one of the companies
Hmm.
in
Hmm.
Bangalore.
Yep.
So some people are saying this DevOps is going to upgrade with some site reliability
Platform.
engineer.
Yeah. Site reliability engineering or platform engineering. Okay. So see,
So
the focus
do,
is,
yeah,
yeah, go on, complete your question.
no, this this SRE, will it replace DevOps or DevOps will be there for a long time?
Okay, yeah, that's a good question. So I worked for a very large company for a long time, before I moved on to startups and other companies. So our company, the team name we had initially was called as Platform Engineering. Okay, or it was simply called as a platform team, right? I'm talking about 2011, 2012. Okay, then you know it's they said, okay, we want this team name as reliability engineering. Okay, then they changed the team to DevOps team. Then they said, okay, we are not DevOps, we are site reliability engineering. Okay, so there is a big, uh you know what do you call, not big, but there is kind of um lack of clarity. See, I would say there should be no DevOps team. There should be only SRE team. Okay, so SRE team is responsible to implement DevOps culture. Okay, but in practice, what happens is these lines get blurred, meaning, you call yourself a SRE team, but you're doing only, like, let's say, basic operations. You call yourself a DevOps team, but maybe you're not doing anything much other than doing CI/CD. So don't worry about that. You have to focus on the skill set. There is very slight difference between DevOps and SRE, and even in SRE, you will need all these skills. Okay, and now we have the new, you know, what do you call, new paradigm coming. Everyone is talking about platform engineering. If you search Google also, or YouTube also, you know, they say DevOps is dead, platform engineering is next. But how does it die? It doesn't die, right? Like, I mean, you still need these skill sets. As I said, DevOps is all about promoting your culture across your team. DevOps has to be practiced by Scrum Masters, QA engineers. Everyone has to practice DevOps like as a culture. But the skill set, it could be useful for you as a SRE engineer or a platform engineer, doesn't matter what the title is. Okay. You see, there is a large overlap of the skill sets, whether in DevOps or SRE. Okay. So don't worry about those. Yeah.
Okay. Thank you, Kiran. I hope this session will continue up to this course without any disturbance. Yeah,
No, I'm
we
also
are
hoping.
okay with
I'm also
this
hoping.
timing. No
Yeah,
issues in that.
I'm
Yeah,
also hoping because right? Because if I take a demo, I mean that I'm serious about my class. I wanted to
yeah,
take, yeah, but if we don't have enough attendance, also it's like, yeah, there is some financial aspect, there is some effort aspect, right? So,
yeah. Kiran, at the end of this course, will you help us to prepare our resume regarding DevOps and right? Can I expect that?
yeah, see, I will not prepare a resume for you for sure, but if you send
No,
me your if you send me
yes,
your
yes, yes.
resume, I can review and say what else you need to change. Okay, that's not a problem.
Yeah, sure, Kiran. Thank you. Thank you so much.
Yeah.
That's all from my end, Kiran. Thank you.
Okay. Thank you so much. Okay, if you don't have any questions, thank you so much for joining on a Saturday morning, and you have a great weekend. Talk to you hopefully on
Okay,
Monday.
thank you so much. Thank you for your
Thank
time.
you.
Bye bye.
Bye, B. Bye bye, everyone.